Imagine a world where quality control doesn't exist. You either have perfect quality and don't need it, or you have no quality and desperately need it. Typically, the latter is more common. Zero quality control is an approach for achieving zero defects in an organization. Zero gives reference to the objective of the ZQC system, which is to produce all products and services with zero defects. The approach was first outlined in the book Zero Quality Control, Source Inspection, and the Poka-yoke System, which outline the main concepts of the ZQC system. The ZQC system is unique in the sense that it did not look to blame people for errors or human mistakes. Rather, the focus was on controlling processes in such a way that the process would not produce defects even if human error was introduced into the process. Dr. Shingo recognized that for the system to prevent errors, it needed to acknowledge that all machines and people will at times make mistakes. With that said, it is important to understand that mistakes can occur, and those mistakes do not have to result in defective parts or even defects. Therein lies the foundational secret of the zero quality control system: mistake proofing. Essentially, the system prevents errors, mistakes, and defects from occurring, which ultimately accomplishes the goal of the system: zero defects. Okay, before we go, I'd like to invite you to consider the following question. And if you are answering this question in our mistake proofing course, please feel free to look through your handouts and review the lecture if you would like to before answering. If not, then ponder this question and consider writing down, commenting, or sharing your answer. How would your life or
Hmm.
place of work be
Hmm.
different if you achieved
Hmm.
zero defects? We'll see you in the next lecture. Let's imagine for a moment that you walk into your favorite store. There it is, the dream product that you've always wanted. Immediately, you begin picking up overtime, cutting costs, and when you have time, dreaming about your new toy. After a few months, you finally have enough. Excited, you run down to the store and grab the box off the shelf. For a moment, you think, maybe I should save a little bit of this money. But that's only a moment. You buy it, run back home to unbox and set up your new dream toy. You turn it on, and nothing. It doesn't function. Crushed, you return to the store where the owner informs you the product is back ordered and you will have to wait a few months to get a replacement. Why would you want zero defects? That's exactly why. Defective products and defects not only impact a business internally, they impact the satisfaction of customers as well. This can result in lost sales, bad reviews, and possibly a product or service that cannot be sold. Many people wonder, is zero defects even achievable? With so much of a zero defect philosophy riding on and changing culture, it can be difficult to see anything other than failure. However, there is much more than that. In addition to improved customer satisfaction and loyal customers, working to achieve zero defects will drastically reduce the costs, improve efficiency, and establish a foundation for problem solving. Formally defined, a defect is any output from a service or a product that does not meet the customer required specifications, standards, or requirements. Though a defect is not the same as defective, they both yield significant costs. For example, when a defect occurs, time, Materials, money, and other resources have been invested already. If the part or information is deemed defective, it is all lost. With that being said, even a defect will cost you money in the form of rework, lost time, and possibly an output that you can do nothing with. Defects also slow a process down. They cause information and products to be reworked, and they often result in bottlenecks or lines that are stopped. On the other hand, when defects do not occur, a process moves more efficiently. When a process results in a defect, the primary objective would be to stop and work through the various levels of causation and discover why the defect occurred. As this problem-solving process occurs, a foundation for problem-solving and improvement-minded people are developed. This is one of the most powerful aspects of the ZQC system, its focus on the process and not on people. As noted earlier, the system recognizes that people are not perfect and that errors will occur. This mindset creates an environment where problems can be brought forward and solved. In addition to this, the system gives people tools that they can use to prevent mistakes from ever turning into defects and solve problems one after another. As you can see, there are many reasons why zero defects would be your focus. From the days of Shigeo Shingo and Philip Crosby right up until today, zero defects is a recipe to lower inventory, improve efficiency, and reduce costs in an organization. Let's now begin looking into this powerful ZQC system and learn how we can begin moving towards zero defects. Nobody wakes up in the morning and thinks to themselves, "Today I think I'll destroy all the materials, products, machines, and information at the place of my work. Yes, that's what I will do. Try to create as many defects as possible." But sometimes, as humans, we make honest mistakes. When these mistakes result in defects, it is important to first allow the problem to be brought forward and reassure the individual that even though the problem has occurred, there is also an opportunity to get better. In the case of a defect, there are some general areas where defects occur, which we will introduce here. Starting with standards, procedures, and processes. First and foremost, we want to look at the process, the standards, and the procedures. When procedures or standards are not established, lots of guesswork can occur. This oftentimes is a key factor in the creation of a defect. If by chance standards and procedures are established and defects are still being created, the standard or the procedure may not be correct. Here's an example. If you're producing a batch of cakes and the process has the wrong ingredients tied to it, every cake will be wrong. The standards, procedures, and processes must all work in unison and appropriately. If they do not, you can be sure a defect will occur. Next is the stability of your process. Variability is real. When your process, machine, or materials have variability in them, you will not be able to produce a consistent output. This will result in defects and is a foundational concept in Six Sigma. For example, a process that has no standard will be performed differently each time, which means it will not produce the same result. A machine that does not run as tight as it should will produce defects from time to time. Likewise, if the materials or information you are using are not consistent, defects will occur. Next, we will look at the effects of maintenance. Another common cause of defects in both parts and information are worn down or not up to par systems. For example, if a computer needs maintenance or is not working properly, it may produce outputs that are defects. A machine that produces parts and has worn down tooling or mechanical parts may also create an environment that creates defects. Next, we will look at mistakes or errors. The final common cause of defects in materials or information is human mistakes or errors. In the book, Zero Quality Control, Source Inspection, and the Poka-yoke System, we learn that even when all mechanical aspects and processes are functioning properly, human mistakes and errors can still occur. This could be forgetfulness, misunderstanding, misidentification, lack of experience, neglect, by surprise, or any other reason. Whatever the reason, mistakes do sometimes result in defects. Unlike the other reasons that defects occur, mistakes are oftentimes unpredictable. So, how do we catch these unpredictable errors? The ZQC system attempts to catch these errors with a control function before they turn to defects. Control functions work by creating an environment or conditions where everything that is needed to create the proper product or information is present. Remember, there are many different ways in which a defect can occur. These 4 common causes lay out a framework that defects can trace back to. However, you may consider making a list of things that cause defects in your process, at your work, or even in your personal life. Try setting a timer for 5 minutes and write down the different things that cause defects to happen around you. As you do this, you may find one example you would like to work on. If you're taking the mistake proofing course, you can answer the questions inside the course. If not, you may consider jotting your thoughts down on paper before moving on to the next section. We've all heard of the traditional process for quality improvements: plan, do, and check. This process is largely based on the check or inspection catching defects. However, catching defects implies the defects have already occurred. While it's certainly better to catch a defect in inspection, it would be much better to control the process in such a way so the defect did not occur. To do this, we need to understand a little more. Traditionally, a process, materials, machines, and information are planned. On paper, the plan looks great. Then the do happens. After the output is produced, inspection jumps in and checks the part. The part either passes inspection or it doesn't. When a part or piece of information does not pass the inspection phase of a process, it is typically rejected as something that does not meet the requirements. The information from the rejection is then passed on to someone for feedback and eventually some form of corrective action, improvement, or root cause analysis. This sounds great, right? In many aspects, yes. Defects should never escape. The downfall in this traditional scenario is that the defect still occurred. And while you may catch and stop a million feedbacks, you are catching them after the fact, not preventing them. Dr. Shingo reminds us in his book, Zero Quality Control, Source Inspection, and the Poka-yoke System, that an error is not a defect. Rather, the error causes the defect. With this powerful reminder, it is much easier to understand that we do not want to discover defects after they happen. We want to catch the error before it turns into a defect. In the ZQC system, this is done by creating an environment where the do and check occur at the same time. This helps ensure that the plan is executed the way it is intended, and if the plan is not correct, it is found right away. Essentially, the traditional method of quality changes from plan, do, then check to plan, do, and check. This scenario performs inspection right at the point or place where an error or problem could occur. This gives frontline employees who are doing the work an opportunity to detect and correct the error before their work is done. ZQC refers to this as source inspection or inspection that occurs at the source. When the inspection occurs right at the source, the feedback is instant and any problem that may have occurred can be corrected before the defect occurs. The zero quality control system works best with implementation of 4 foundational elements that we will introduce here: source inspection, 100% inspection, short feedback loops, and poka-yoke or mistake proofing. These 4 foundational elements have been proven to effectively help move from a process of inspection to an environment of a process control. We will discuss more in the coming modules.